All right, in this video, we're going to be focusing on our confidence interval, our sample size, and our margin of error. So we really want to look at the relationship between all of these values. So I have an example for you. It says that a population has a standard deviation of 17.4. It wants to know how large a sample must be drawn so that a 95% confidence interval for our mu or our mean will have a margin of error equal to 4.4. So there's a formula that you use for this type of example, and I'm going to write it right here. We have n, which is our sample size, is going to equal our critical value, z alpha over 2, times our standard deviation value all over our margin of error, which is denoted as m. And then this is all going to be squared. So one of the very first things that we need to find is our critical value, or our z alpha over 2 value. So from a previous example video or from class, you should know to find z alpha over 2, we need to look at our confidence interval of 95%. And remember that finding this critical value, we're going to use our command in our calculator, inverse norm. Second bars, inverse norm. Now we're dealing with, when we're finding our critical value, we're dealing with a standard normal curve. So you can see over here in our window that our mean is going to be 0 and our standard deviation is going to be 1 for this part. So let's find our critical values. So remember that with our critical values, we're given the area in the middle of our curve, so 0.95, and we're trying to find this value right here. So we need to find this area to the left. So because I need the area to the left of that value for my inverse norm. So the first thing we're going to do is we're going to do 1 minus 0.95 divided by 2 to get what that area is. Now I do this directly into my calculator, and I will show you that here, because when you do this, 1 minus 0.95 divided by 2, oops. The cool thing is then you can go all the way down to paste and press enter. And what we're going to get here is the negative value to the one that we want. So our positive value right here would be 1.96. Now I do this because I know that the positive value is what's going to be on the right and the negative value is going to be what's on the left over here. And we know this because we're dealing with a standard normal curve. But if you need to do this all the way out, I understand. The way to do that is you do 1 minus 0.95 right here. Divide that by 2, and you get 0.025 as your missing value. And then if you go back into your inverse norm and do 0.95 plus that 0.025, you will see that we get the same answer, just the positive version. Alright, now that we have our critical value, we can do what we call plug and chug. So our critical value, this guy, is going to be equal to 1.96. So we're going to replace our critical value right here with 1.96 times, now my sigma value or my standard deviation value is given right here of 17.4, and then my margin of error is given right here of 4.4. And then what we're going to do is we're going to square this number. So moving over to my calculator. Now the cool thing that your calculator does here is if you press alpha y equals, you can choose to do a fraction directly into your calculator. So I'm going to do that here just so you can see that demonstrated. So I'm just going to plug in 1.96 times my sigma value of 17.4 excuse me, divided by my margin of error of 4.4, and then this entire thing is going to get squared. Alright, so if you notice, I get a value of 60.08. But the thing about a sample size is you can't have 0.08 of a person, right? Or a duck or whatever it may be that you're sampling. So you're always going to round this number up, no matter what's behind that decimal. So this is actually going to equal 61. Now for the B part of this problem, it says if the required confidence level for 99.9% were 99.9%, would the necessary sample size be larger or smaller? Well, think of it this way. If you increase your confidence level, then you're going to increase your critical value, and therefore your sample size would become larger. So because we went from a critical confidence level of 95% to 99.9%, I know that my Z alpha over 2 value, or my critical value, is also going to increase. And if that one increases, I know that my sample size is going to increase. So therefore, it's going to be larger.